We need to find a better primality test than trial division has turned out to be for very large numbers. So we're going to get there, but we need a little bit of prep work before we can really delve into these other approaches. In this video, we're going to start off by talking about modular arithmetic. Modular arithmetic means treating a number not as itself, but as the remainder you get when you divide by a certain other number. So in the example here, 72 mod 7. 72 mod 7 means divide 7 into 72 and take the remainder. And so here the answer would be 2. And so what we can write is 72 is the same as 2 mod 7. Now instead of an equal sign we use 3 bars. Okay, and sometimes that's written congruent. So 72 is congruent to 2 modulo 7, or you can just say equals 2 modulo 7. It's all the same thing. But basically 72 and 2 are the same thing when you're thinking of numbers mod 7. Another example might be 23 and 8 are equal mod 5. They are congruent mod 5, right? Because both of them have a remainder of 3 when you divide by 5. Okay, so 23 and 8 are congruent or equal mod 5. Now, a nice way to think about this might be, instead of, our usual way of thinking of numbers is on a number line, right? So 1, 2, 3, etc. And so we could locate 8 and we could locate 23 further down on the line, and they would be at different points on the number line. But in a mod 5 world, think of the number line as wrapped around itself into a circle. And so as you move this way from 0, 8, right, would be 1, 2, 3, 4, 5, 6, 7, 8. 8 would land right on top of 3. And of course 23 would also, right, if we went around, we'd go around 4 times and then land on 3 again. So it's like a circular number line, and you count that many steps clockwise from 0, but now you have the option of 2 numbers landing on the same spot, really. So on this number line, they are really the same. Our clocks are like mod 12 devices, right? So that's the idea. Now when we proceed to do arithmetic in this kind of number system, in say a mod 5 number system, we can take some shortcuts. Let me show you. Suppose I want to work out what 317 times 209 is mod 5 in a mod 5 number system. Well, of course, one way I could do it is simply multiply 317 times 209 regularly, getting 66,253 mod 5. And of course, that would have taken a minute or so by hand, or I would have to use my calculator. And then once I get it, I can see, okay, when I mod 5, I'm going to get 3 mod 5. Mod 5 is a particularly easy one because you know that it's all based on the first digit, right? Whether it's 0 or 5, that goes in evenly, and then you can count from there. Okay, but another way to do it is, it turns out, and you can prove this, that you can mod 5 each of the numbers individually first. You can do 317 mod 5 and 209 mod 5, and then multiply those results. So 317 mod 5 is 2, right, because 5 goes into 315, and 209 is 4, and so I get 8, and then mod 5, that would be 3. So you see, I never had to go up to a very big number. I can sort of mod 5 the numbers individually and then multiply, and it turns out that you'll always get the same right answer. And this works for addition and subtraction, and as you see, multiplication. So this is sometimes this makes things quicker, especially when you're dealing with big numbers, which we know we're going to be dealing with big numbers.